You've got your 3D printer set up, humming away, and now you're wondering to yourself, what else do I need? Stick around to learn about some useful things to get, and why this little bag here is one of the things I've gotten the most use out of. Phil here in the layer by layer layer. I've already gone over upgrades you can print yourself with the 3D printer, and I think printers printing printer parts is particularly perfect. But there are some things you can't print, which is what I'll be covering in this video, starting with modeling software. Broadly speaking, there are two main flavors: 3D graphics programs, which are great for artsy models, and parametric modeling programs, which are better for precise, functional prints. But we'll get into the details of that a bit later. Now that it's a bit later, I'll go into some detail. I'll start with the 3D graphics applications. These programs work by building things with primitive shapes and then sculpting them like digital clay. For this, I like the free program Blender. Blender is what I use to make my Minecraft movie creeper, the Simpsons donut, and my Kirby vacuum attachment. Kirby offers a good example of the basic workflow, mainly because he's a sphere with some blobs. I created a sphere for the body and a sphere for the feet before using sculpting tools to shape the arms and smooth things out. More details about the process for Kirby and all the other items I mentioned can be found in the other videos on my channel, which I encourage you to check out after this. Parametric software is a little different. It's less digital clay and more like giving your computer a recipe. I like to use OnShape, which is completely online and has a free tier. As I mentioned earlier, this method of modeling is good for functional prints, which is why I used it to make my telescope eyepiece holder. Parametric design allows you to set specific dimensions either explicitly or in relation to other parts of the design. The big advantage here is you can change a single dimension and the software automatically updates everything else. The downside? Sometimes there are incompatible instructions, which can be quite frustrating to figure out, especially when you're a novice, which I very much am. Of course, if you're going to do something with specific dimensions, you're going to have to accept that sometimes size really does matter. And you'll need something to measure things, and that means a digital caliper. A digital caliper, along with being a bit of a tongue twister, digital caliper allows you to precisely measure both the outside of an object or the inside using the arms, hooks, pointy bits. One sec. It turns out they're called jaws. With that cleared up, I'll start by showing how to use the bigger jaws. These are used for measuring the outside of something. You make the jaws open wider than what you are measuring and then gently close them around it. You don't want it to be too tight or too loose or you won't have an accurate measurement. The smaller jaws on the top are used to measure the interior of something, but instead of closing around the object, you open it up as seen here. If you want to get your own, you can find links to this and everything else I'll talk about in the description below. Now that you've got some of the things you need to make your own models, we'll turn our attention to some of the things you'll need to actually print those models. The first category of things I'll talk about are adhesives. When you think about glue, you likely think that it's needed to increase adhesion to the build plate. After all, glue is sticky. And for some materials, such as ASA, you'd be correct. Glue can prevent warping, like I saw in my telescope eyepiece video. However, there are some materials like PETG, which is a bit clingy and really likes to stick to the build plate. And the adhesive is used to make it easier to separate. There are a couple types of glue you can use. One is the basic Elmer's or generic brand washable glue stick, which I don't have B-roll for because all of them seem to have gone to school with Imogen and Imagina. This works really well with PETG to prevent over-attachment. For ASA, I prefer a liquid glue, such as one from Bamboo Lab, though I've heard really good things about the Magigoo line of liquid glues, which are engineered for specific materials. If you've used them before, let us all know how it went in the comments. Whatever glue you're using though, you simply need to slather it on the build plate. Though note that you'll have to remove the cap if not shooting B-roll for a video. Adhesion isn't always your friend, like at the hot end. When issues happen with a print, filament can end up sticking to the hot end, which can cause a buildup that eventually leads to the blob of death. To prevent this, Slice Engineering has a nozzle anti-stick coating. It provides an extra layer of protection for your hot end. You just paint it on, and then when the hot end gets hot, it will bond to the metal and plastic won't. Now you've nailed the print. Perfect bed adhesion, clean hot end, everything's looking good. But you had to use a brim for stability, and now your masterpiece has a little plastic tutu around the bottom. Most of it peels off, but there's always that annoying lip left over. That's where a de-burring tool comes in. It's basically a tiny plastic shaver that lets you trim those edges clean. Next up, moisture management, because filament is basically a sponge in disguise. It's hydrophilic, which is science speak for sucks up water like Kirby sucks up enemies. Or I guess in my case, dirt. Certain filaments are worse than others, and in some cases, such as PETG, you should dry it after unpacking, even if it was sealed from the factory. I've got a relatively cheap filament dryer from Sovol. Of course, you can go more expensive and fancier, or even DIY your own using a food dehydrator. To use the dryer, you put the filament in. I know, real rocket science here. You power it on. You power it on. You power it on? Okay, maybe it is rocket science. You go look at the manual and you are reminded that you have to press and hold onto the power button. Then you change things like material or temperature or time and let it run. After starting it, you'll want to open the vent on top to let the moist air escape so as to not turn it into a steam bath. Once your filament is nice and dry, the trick is keeping it that way. For that, I use vacuum seal bags, desiccant beads, and yes, that little mystery bag I showed at the start. I bought these Amylin reusable vacuum seal bags, which came with this battery-powered vacuum pump. I also have a manual pump, but let's be honest, if there's a button I can press instead of exerting myself slightly, I'm pressing the button. The bags also came with regular desiccant packets, but I wanted reusable rechargeable desiccant packs, which is where the little bags come in. I take my rechargeable silica beads and pour them in, close it up, and now I've got a desiccant bag that changes color as it captures moisture. And it's rechargeable. Using all of the above, we can now store the dried filament. To do so, place the filament in the bag. I know, more rocket science. Put the little baggie with desiccant in the middle, and then seal it and vacuum out as much air as possible. Now you've got a sealed bag with color indicating desiccant in the middle to let you know it's still working. All the things I mentioned are linked down in the description, conveniently located right under the like and subscribe buttons, which you should definitely click. After that, consider checking out one of these videos next.